Good morning, class. Welcome to Coach Taylor's YouTube of how to find the area of composite figures. I do not want to be ridiculed because I'm not a professional YouTuber. I'm going to try my best to do this to help my students out, and I hope I can teach you something. I hope everybody's well, and we'll get into module number 4, our COVID-19 module number 4, and we'll find the area of some composite figures. So let's get started. First thing you need to notice in module number 4 is at the top of the module you have a page, and on that page is the different formulas for area of all the figures. So I have area of a square, area of a rectangle, area of a parallelogram, area of a triangle, area of a trapezoid, and area of a circle. Now understand, on circles you can also have hemispheres, which is half the circle. So to find the area of a hemisphere, I would take pi r squared and divide that by 2, and that would give me my hemisphere. Again, these are located in Canvas in module number 4, and they are the area and volume formulas page. So that's where those are located. Now today we're going to do 2 examples, and those 2 I did have 3 examples, but I changed it to 2 for time constraint purposes. So let's get started. All right, first example. First thing I need to do is I need to identify what shapes I have in this example. So I look at this example and I see right off the bat, if I was to connect this point and this point, I would have a rectangle. Okay, and out of that rectangle I have a triangle. Now the triangle is not shaded, but the rectangle part is. So that triangle has been cut out of that rectangle. So I need to come up with a plan. And my plan is this. Number 1, I'm going to find the area of the rectangle. Number 2, I'm going to find the area of a triangle. Okay? And then once I find the area of the rectangle and the area of the triangle, I'm going to take and I'm going to cut out that triangle. So the definition of cut out in mathematics is subtract. So in this case, I'm going to take the area of the rectangle and I'm going to subtract the area of the triangle from it. Okay? Now, to find the area of a rectangle, I take and I multiply the length times the width. Now, if you look at this rectangle here, I have 21, 27, and 20. Those are the measurements. I need to find out which one the length and the width is. I know right now that this side right here is 21. Okay? That can be the length or the width. And I know this side is 27. And that side can be the length or the width. It doesn't matter which one you use. This 20 here is the height of that triangle, how tall that triangle is, and we'll use that later. Okay? So what I need to do is I need to multiply. I need to take and I multiply 21 times 27, and that gives me 567. Okay? Now that is the area of that total rectangle. Okay? So the next thing I need to do is I need to find the area of the triangle. To do that, I take the base times the height and divide that by 2. Okay? So the base of this triangle is this part right here that it sits on. I know right now that is 21. So I'm going to take 21 and I'm going to multiply it by the height of that triangle, which is 20. And I'm going to divide all that by 2. So that's going to give me 210. I'm cheating. I've already done the math. Okay, so what I need to do is I need to subtract 210 from 567 to find the area of this composite figure. So we take and we go 567 minus 210, and that's going to give me a total of 357. Since it is area, that's going to be centimeters squared. And that is the area of this figure that is shaded right here. And this is minus that. And that is how you find the area of that example number 1. All right, let's look at example number 2. Example number 2, I need to find out what it's made of. So I look here, and I look at this side. Looks like to me it's going to be a half circle. A half circle is called a hemisphere, and to find the area of the hemisphere, I'm going to take area of hemisphere. To find the area of a hemisphere, I take pi, which is 3.14, times r squared, the radius squared, and I divide that by 2. Okay, that's the first figure. The second figure, number 2 figure, is a triangle, of course. And to find the area of a triangle, area of triangle, okay, to find the area of a triangle, we take the base times the height, and we divide that by 2. Now, both these figures are shaded, so I need to find the mathematical term for combining 2 figures since both of them are shaded, and that would be addition. So I'm going to add those 2 things. Okay, so let's plug some numbers in and see what we can get. So let's take pi, which is 3.14, times the radius. The radius of this hemisphere is 4, times 4 squared, and I'm going to divide that by 2. That's going to give me a grand total of 25.12. Okay? All right. I found the area of that hemisphere. Now let's find the area of the triangle. All right. We're going to take the base, which looks like to me it's 12. We're going to take 12 times the height. Let's look at this. From this point to this point is 4. If I double that, which is going to be the height of that triangle, it's going to be 8. So you have 4 here and you got 4 here. So this is 4 and this is 4. That would make a grand total of 8. So I'm going to take 8 times 12, and I'm going to divide that by 2, which is going to give me a total of 48. All right. Now we're going to combine by adding the area of the hemisphere to the area of the triangle. So I got 25.12 plus 48. And that's going to be equal to 73.12. And since our measurement is meters, this is going to be meters squared. And that concludes our lesson of composite figures. Be sure that you do all the work. If you need more help, watch more video that's on the module 4. And if you need more help than that, be sure to contact me through Canvas. I appreciate you paying attention today. Hope you have a good day. Stay safe.